may be more than one children from the same, be in one data set with just the father's name, and the other binds you that whether it's going to be one-to-one merge or it's going to be one-to-many. Okay? So that is one of the things that can happen if you are not joining those data from one to the other data sets. Can you follow what we just talked in the last class in terms of that what these assumptions are and how we want to make sure that those are tested? We are testing those assumptions. Okay? We also talked about the different kind of problems that happen if those assumptions are not satisfied. And then we were talking about that what are the different things that we can do to make sure that we have addressed these issues. So you can see that in the visual part, we are looking, we can do it, different things that we can do. Okay? The first one is looking at calculating the residual, okay? And then we are going to merge that with the fitted value. Okay? So let me try to see here. इस पे नहीं दिख रहा ये वाला? So after you have run the regression, you have to calculate the if you look at some of the basic things we are trying to do, that we have the regress is the command. We were referring the dependent variable with dv, okay? And we are referring the independent variable with iv. Okay? What is the advantage of using this in this fixed format? Can you think about, is there any benefit of grouping these variables in this way?
There is no need to typing different variables. If we use this set of variables, sliding down.
Thank you. Thank you. Thank you. Okay. So there are two types of macros in Stata. Okay? One is we call global macros, and the other is called local macros. So you can do the same thing. You can refer them using global or local, a set of things that you are referring them. You can call them using a local command, and you have noticed that I was using global mostly and not local. Okay? So the difference is and you have to be careful in when to use this versus not. There are trade-off involved in doing this versus. The one advantage is that if you write really a good do file for your a project, and if things are organized well, you can actually use the same do file for a different project also, quite a bit, okay? Because some of these things that you have done, all the due diligence, all the residuals and things that you have done, if you follow this style, then you can actually do that. And the local, if you use the local macros, every time you select, so let's say you define them the one time, okay, and you are operating later on after 3 lines, 4 lines, and you call them, they will not change once you have defined them throughout the program. It will not change. With the local, every time you have to select, otherwise it will get redefined. So they are not. So every time you select, you have to select the local also. But with the global macros, in the beginning, let's say you have defined them, that these are my global ones, and I'm going to use them throughout that. Okay? So if you are changing, let's say IV, you are using a different set of variables, but you have not made this change, then it will be still referring to the old one. Okay? While you are thinking that I want to refer to a different set of variables, but if you have not redefined it, it will, because it's in the one session, it will continue to be in the memory, and they will continue to use that. Okay? So that's one part. And if you use so this is a very simple style, okay? That any model will have a dependent variable, okay? And it will have an independent variable. Now, there is no group involved here, because dependent variable is usually like one variable, but I'm still using a different one. The reason is because then it becomes portable. My file becomes portable, okay? That in this project, I have this dependent variable. In another, I may have a different dependent variable, okay? But my all commands are written that it has a dependent variable, and once I define it, I don't have to modify anywhere anything else, okay? Because it's set, and the same thing can be applicable anywhere else. Now, once you have done that, then the first thing we have to do is, now we want to do, let's say, the predict, and you can give whatever name. So the predict is going to look at, so it's a new variable that you are creating, okay? It is coming after the regression that you have got the output. Now you are doing the predicting part, okay? Let's say, and it's a name. You can give whatever name you want to give, but you are predicting a variable, and then you will tell what this is, okay? So the data knows that, okay, this is, you are predicting the residual, okay? So I want the residual to predict it, because for this graph, to generate this one, I need 2 predictions, okay? The predictions about the residual. So the residual, what the residual is, essentially, is the difference between the observed value and it's the predicted value. The difference between those two is, so what we are trying to see, that if our predictions are good, the residuals will not vary too much, okay? They will be, the estimations will be close to that. So we want to see if there is a pattern that, okay, once, and the second one is, so we needed 2 things. Okay? So the second thing we needed was to predict, let's say we are calling y hat, and then this is Stata's way of calling them x's, okay? So it's a matrix, if there could be 5, 6, 10, 15, whatever. So they are referred as that way. So it is knowing that you want to predict the y, the dependent variable. That's what you're trying to predict. And once you have done these 2 predicted, then we can generate the graph. that, and it allows us the visual inspection. Let me see if I can go to the file, because it's just the different when you generate the output, you also want to save the results in a form, and you may have multiple models. Okay? So you want to be able to generate or produce a table, okay, that how I get the results that shows up on the screen in a format that I can show. And you may have multiple models, like in one, the control model, you have set of variables that you are using as a control variable. Then you have the another variable that you are, let's say you have one hypothesis, so there will be the next model, and then it's a growing order. Okay? So as you keep adding more variables in the subsequent models, so each one will be a separate result. Okay? So now you can see you may have 5, 6 models that you need to report. Now how to actually get those in a tabular format? So you can do one option is it's a manual part. Okay? You can go and try to manually edit, but you can in a tape, like in a paper, maybe you are interested in like 3 places after decimal or 2 places after decimal, standardizing the output. So one is the manual part. You can look at and just customize, copy, paste. But the problem that happens with the copy paste, there is always a risk of an error, that you copy something from one model and you paste it in a different one. Because you are doing it manually, there is always a risk that there is something has wrong. So a few things that's the reason we want to stay at the do file, and everything that you'd want to do, you want to do it here. Okay? Nothing that there will be temptation, because you can see, okay, I just need this part, I can copy and paste here, and that will be faster and quicker. But that's where the mistakes happen. So the mistakes can happen that you did something wrong. The mistakes can also happen that you just made a simple copy-paste mistake. And the copy-paste mistakes are very common, and the reason is that people produce their tables manually. Very few people actually generate through the program itself. So when I want to do things, so everything I want to do through the do file. And this is why it's very important. And then there is a way, so and there will be, when there is a large project, you want to organize your do files with a theme. Okay? So let's say there is this file, you can say, okay, I'm just going to build my data set. Okay? So you can say, okay, this is, and then you have to have an order, okay, that in which order do files will be run. So those are part of that how you organize your files, because if somebody was doing, okay, so they missed something, and they say, okay, they're doing it, it's showing error. Okay? Because if you run something out of order, the next do file is making use of a variable that is an output of a variable, the file that has to be run before it. Okay? So if you don't run them in the right order, then it won't work. Okay? And it's up to you, like how you want to organize and how to. So there are 2 things I like to do. Okay? So there is one do file where I'm writing down only the sequence of the do files, which we call a master do file. Okay? So typically, each do file will have a theme. Okay? In this one, I am merging my data sets. In this one, I am checking or cleaning my data set. Okay? So all I'm doing is cleaning, and I can name them like that. Okay? So it's cleaning, and then there will be places where I will be running them. And let me see if I can quickly show you one of these schemes, like from my own work that I have done. And let me see if I can quickly show you how to organize it. Okay. So now you'll see there are many do files. Okay, so all those files are, first thing is kept here. Okay, all of them show up here. You will see that I also try to follow some simple ordering scheme. Okay, so the do file is, first one is beginning with some name it has. Okay, merging compute stat with SDC data set. So there are two data sets it's merging, but I have put a 1 before that. Okay, then the next one is with the name, but it is starting with 2. Okay, so I know I can't make a mistake that the 1 is going to start first, 2 is going to start after that. Okay, now you can see the third one is 3, 4. So these are thematically organized, and I have put a number in a way that I can't make a mistake in terms of which one, because you can see that it's a big project, so there are many files and many pieces of data that come from many different parts. Okay? Now, I have a master file. Okay? The master is trying to run it. Okay? So it's trying to right now run, but the master do file is which is everything is listed. Okay, so the way you want to organize your project is that no matter who you ask, if you ask somebody else, okay, that here's my project I'm working on, can you get the results? Okay, if you have, without you giving any other instruction to that person. If everything is organized in a way that no matter who looks it will do the same thing, then you can see that yes, I have done it. So it requires a lot of detailing. Okay, so if you look at the, I'll show you that you have to use the steps, put definitions. Okay, what exactly I'm trying to do here. Okay, and you can see there are some ones that are showing the green color. Okay, so the ones, the lines are showing with the green color, so I'm just putting a star in front of that comment. Okay? So it's a comment which is telling me that, let's say if you write all these things, after some time you may forget that what exactly I was trying to do here. Okay? What was the purpose? What exactly was the purpose of this command? Because you can see the command, you may not remember what exactly I was trying to do here. So when you are writing it, you make a liberal use of commenting inside. Okay? And you just put a star that the data knows that it's not a command. Okay? So you can see the color scheme is automatically coded because it recognizes that which one is a command, which one is not a command. So that its file is organized in a way, and it provides the enough sort of description that a month later, because many times what happens, you're working on a project, and then you may have another project, and then you are coming back to the project that you are working on. Okay? It usually takes about a day or two just to figure out, okay, what I was doing on this one. Okay? If your files are not organized very well, it's going to be a huge problem. But if you have organized and instructed, so this, in terms of doing what we call a reproducible research, how you do a research that can be reproduced. And that's the quality work. Okay? And the first bar is there, that the reproducible work, you should be able to reproduce your own work. Okay? That what you got the last time when you were working on it, you had some results, some things you were seeing. Can you get the same thing after 2 months or 3 months? Okay? If these things are not organized with the discipline, because it's always, you can see that, oh, I can actually get faster from the click thing. Okay, so there is this data. Some of you who are familiar with SPSS, okay, so you can actually use the mouse to actually run all the commands, and you can do everything here with this data also. Okay, but I never recommend anybody who's learning that you actually use that, because it's easy, and in the beginning maybe you can try, and because when you click those things, it will also show the command. Okay, so for example, let's say you are not understanding that, okay, what command I should get. So there are two things. First is all the every data comes with a huge documentation, okay, PDF files. You can see there will be at least 2,000 pages or more, maybe 5,000 pages of manual. Okay? The manual in data is organized for different, like time series, there is a one, longitudinal panel data is one, the graphing is one. So there will, you can see at least 15 or 20 types of material that it's a detail, and that's very, very important source to actually learn that. Okay, you want to learn where to go and learn things. Okay? Somebody was asking was, okay, is there a book that I can actually follow? Yeah, I mean, and if you look at the references, there are books and things are written. That's a good one. But the best place to start is just reading the manual, okay? Because it's a very well written, and so you want to kind of so something has happened. Okay, was denied. Okay, that's good. In order to run a do file, so you can actually, we were doing it more like an interactive way. Okay, I was asking you to get, can you select one line or two lines and run like that. So if you look at the files, so you have to first make sure that you are writing the commands that work. Okay, because you may have a very long line, and if there is an error in the do file, it may not run because there is a mistake, it will stop. So it will come with just a red line. And earlier when I was like way back, the computers were very slow, and we will give the commands in the night time, let the computer run the whole night, and come back the next day to see what outputs we got. Okay? Now many times when we come back, they'll say, okay, nothing happened. Why? Because there was some error in the do file and it got stuck. Okay? So you come back the whole in the mornings excited, maybe I'm going to get something, and it will not. So it's okay to, when you are writing it, you can run it by piece, okay? That, okay, is this command, is it giving, it's doing what it is doing, okay? Or what you expected or you wanted it to do. But once you have done that, the next part, you should be able to select the whole, all of it, okay? So for example, in the do file, the early part, we was doing the directory, okay? So you have to put a star on those ones, because once the folders have been created, you don't want to run it again, because already it will give you an error message, okay? That, oh, this is already, it's already exists. So once you have done this, the reason I put it, because it's a very good thing for any project you are starting, you are creating a structure, okay? The structure you are creating, that, okay, there is a project name. In the project name, a similar structure, because those are all applicable to any project. Okay, so if I show you my project, like files, they're organized just like that. Okay, there is a data folder, there is a raw data folder, and those are things, the discipline that you want to follow. That, okay, I'm not going to touch the raw data, because raw data has come from a source, so it has to be there. At all processing you're doing with your do file. You are not changing the raw data, because once you modify the raw data, then you will be in trouble, because now you change the raw data itself, because anything that you are doing can modify the data set itself. So you want to keep the raw data, and typically I actually also give a name to that okay, still it's wrong. So there are some issues in terms of the wireless. So because everything is saved in the Google Drive, and there's one thing I do, because that way I'm independent of my computer. Okay, I have a workstation that is in my office, and wherever I am traveling, I run my programming by remote logging in. Okay, and I have a secretary. If sometimes there is a power outage or something, I have to ask her to go and restart the machine, because if there was a power outage, it needs to be kind of restarted. So by having everything in the cloud, I can run remotely any part that I'm. Some of the things are part of the learning is that what kind of discipline is required to do things. Okay? How you want to make sure that you are following the right kind of process. So once you can choose, you have written all these one by one bits and pieces, and then you want to see that, okay, if I choose all of them together, is there any error in the file? Okay? So that, because you are doing interactively early on, so there was probably not much error, but there was something if you did manually and there was a missing part, it will break. The command will break, and it will show that there is something. It did not find something. It didn't find something. Okay? But once it is written, there is another discipline that that we actually need, is that once you have checked a file fully and it has done, it was at, so I usually put what are my input files, okay, in that, and what are the output from that do file will give. So that way I know in this do file what are the, where the inputs are coming, what inputs I am using, and what are the outputs I am getting. So by simply looking at my do file, I will know that what should be the output that I should be looking at. So because you can see it becomes, as your project grows, and if you are working on a big project, there will be like 15, 20 different do files. You will have about 30, 40 data different pipes, because each one, if you save, it creates a data file. Okay? And after few parts, like we just saved one, okay, like workshop.dta or something we created in that, and we are running it. But every time like you are running something, so there will be a file, there's like a graph file that you will be creating and saving. So we want to do it in a way that even after some time, you can go back and check where things are and whether they are done or not. And the one, okay. Anyway, so it's giving some kind of error here. I don't know why, but let me just see one more time. Okay. Now you will see here, these are all data files, okay? And there are many, many data files in that. But you will also notice that I have one folder inside, which is a raw data file here, okay? This raw data file, if I have something that comes here, I will not going to touch that at all during the entire process. And I'll show you one more thing that I try to do. Okay, it's not connecting with the internet. Can you help me with this? So it is disconnected, and that's why it's giving me the error. Okay, now it's connected probably. So it's coming and going, this D-Link workshop thing. So I don't know what's going on here. Right now it's connected. But let's see here that, okay, it's just coming all kinds of this. complicated stuff. I don't know what's it's going. See. Okay. It comes and goes away. I don't know. Yeah.
No, you can manage.
Okay. Let me see one more time. So if you want to run the entire do file, now here you can see it's trying to run. So it's saying do edit, okay? And the file it's trying to run is the master do file. I didn't intend to run it, but it is right now. It just clicked it and it's running the master do file. So the master do file has all the files in that order. Okay? So every do file has been placed. The discipline that you have to follow is that once you have run a do file that fully does what you want it to do, then you don't go back and touch that again. Okay? So it's done. You're not going to touch that again, because that way you take a big project, you make it into smaller parts, each component, you handle those components individually, and you make sure that, okay, I did this part, this was the task I needed to do. In one sitting, you will focus on one or two things, okay, that today I'm going to do this part. And you wrote a do file for that, and you are going to, so once it becomes fully functional, you don't change it. But you can see that it is calling this master file. In the master do file, there are many do files. Okay? So if my master do file is functionally fully fine, it will not show any error. Okay? Now it's running in the background, but it's not showing me any error because it's running and it is finding what are those different things that it needs to run and what should be their sequence in which you want to run those. Okay? Now, we created a data set which was more like a panel data set. Okay? The workshop.dta that you created, okay? If you remember, we had 12,000 observations, but there is if you check, there is an ID, firm ID. So there may be, like, I don't remember how many companies are there, but we created what we call a balanced panel data set. Okay? What is a balanced panel data set? There are, anytime you look at a longitudinal data set, then you have multiple observations on a given entity over a period of time. In a balanced panel data, you will have the same number of years for everyone. Okay? So let's say you have looking at 100 schools or 100 companies or 100 districts, okay, for whatever project you are working on, and you are looking at 10-year data of those 100 units. So in a balanced panel data, you will have these for 10 years for each of those. Okay? In the unbalanced one, there may be the companies, let's say you are focusing on one industry. Okay? So in that industry, there are companies that are created, and some of them were like merged or acquired or may have gone bankrupt. So they have observations, but they have observations of only for a few years in the data set. Then there may be companies that are forming a little bit later. So you started, let's say you have a 20-year data set, but in that, let's say in the telecom industry, you are looking at, I'm looking at the telecom industry, I'm looking at all the companies that are. So there will be companies that are appearing in the data set later. There are companies that have started, but they don't stay all the way until the end. Okay? So that, and the practical data sets will be more like that, which will be unbalanced data set. But the one that we, because we built it, panel data set. Okay? Now you can see here that in this one, we have, so this is the description. Okay? And the description is telling me that what kind of, so we know that there were 12,000 observations. Okay? But it is also it's saying n is equal to, so there are two n's here. One is the capital N, which you see here, which is giving us the information that how many total observations were there in the data set. Now, the next one, it is showing small n is equal to 600. Okay? And below that, it is showing t is equal to 20. Okay? So these are the three pieces of information that are showing up in my, when I did, and here in the previous version, when I asked you to write SUM. Okay? You remember I was asking you that, okay, can you type SUM to summarize the data set? We were not treating that data set as a panel data set. Okay? The data set is the same. Okay? We are running, you can ignore these, that these are observations for the same firms. Okay? But anyway, we had built a random data set, so the observations were not correlated within a firm. But if there were firms, how those data will look like now, the same data set, we are treating it as a panel data set. Okay? So in order to describe that, the data follows a little bit of an XT, okay? Where X over a period of time, so that's how they have kind of created it. But the last part is also still the same, so it is summarizing the same data set, but now we are treating it as a panel data set. Okay? So what we got, we get from here, that the same information, there were 12,000 observations, but now it is telling me that there are 600 companies. So we created 600 companies, and that is for 20 years. Okay? So it's a balanced panel data set. So we have created 600 companies, and for each company, there is a 20-year data. Okay? And because it's no missing data for anyone, so it's just a multiplication of that, you will get the 12,000, just 600 multiplied by 2. So this is how the data structure is. Okay? That look at visually, okay, because this is how we created. Okay? Now, in this one, the ID is the company ID. Okay? And we said that if we summarize, if I sum ID, what should I see? If I write, can you see that, what I'm writing? I'm writing some ID, okay? What output do you expect? So anytime you run something, you need to know that what I am expecting to see. Then only you will know that what it is showing is correct or not correct, okay? So I need to have an expectation that, okay, if I do this, what I'm expecting to see, okay? And it's part of the learning, so I'm not expecting you that you know the answer, but I'm asking you to, okay, if I do that, what do you think, what should I see? If I'm just going to write some ID here. So what kind of, yeah, what those numbers should look like? So what will be the minimum, what will be the maximum? Okay, that's one answer. Okay, so start with 1 to go to 12,000. Any other person, what should be that number if I do some ID? So the maximum is 600. So I should see, because I started with 0, okay, that counter has started from 0, not from 1. Okay, if it started from 1, then it will go to 600. Okay, but because we started from 0, the counter, it's going to 599. Okay, so we need to have an intuitive sense of our data, that what kind of data I have, what kind of structure I had. So then only if it shows, let's say 12,000, okay, because we have 12,000 observations, okay, that should show here. Okay, if you look at here, it is showing that there are 12,000 observations. Okay, but what we are looking at, that how many unique observations are there. Okay? So if I do, so this is another way to check my data. Okay, so this is, let's say, I want to see if it may not work. Okay, so it's not still there. So there are, in this data, you can also get commands that are written by other people. Okay, so those, just like in R, you can actually get user-written commands. Okay, and there is a way to kind of import those in your data where you are saving all these commands. So you can be also, so usually Stata is very good, way better than R, because what happens in R, there are many people have written, so it's free, so that's the good part of it, but there is always a catch in things that are free, okay? Because there are many things that are written and there are many dependencies. So one part of a program is dependent on other parts of the program. And some of them get updated because somebody is pursuing that, and some people leave that. Okay, they did something, it needed for them at that time, they made it available. But now they are working on something else. It's not they are going to update it as the newer versions come. Okay, so you will see that the compatibility issues are always there. So this set of R commands are compatible with this version of R. Okay, and when the newer version has come, so it is a very fragmented world, and which is sort of expected, okay? Because there is no unifying sort of force that is involved. Even so, the good part for this data is that it has both. Okay, it has the user community, so you can get user written ones, but there is a driving force that continue to integrate and provide a polished version of the commands. Because anytime you will get the Stata command. So for example, we want to compute marginal effects. We want to compute how the interact, because those are the things that are important, okay, in your hypothesis, that you are expecting that there is an interaction effect. Now, the interaction, especially if it's a nonlinear model. Okay? So nonlinear model, so we were doing, the regress was a linear model we were doing. Okay? But there could be your dependent variable is only count observations. It's a positive integer or integer. Okay, so it's a skewed data set. Okay, there is no on the negative side. The minimum could be 0 or 1. So if you try to fit the regress on that, the coefficients will be biased. Okay? So for fitting those, we will look at, okay, so if the numbers are like integers, like 0, 1, 2, 3, 4, 5, 6, like that, then there are two alternatives that we can fit. And we'll talk about tomorrow in terms of some of these kind of models, that how to, so there are two ones which you can run. One is a Poisson model, and there is a variation, which is the negative binomial. Okay? So those are the two you can fit to model a variable that is count data. Also call them, it's a count variable. You look at the dependent variable, it's a count. If a variable is what we call a dichotomous variable, okay, usually a choice, that are you going to do this or not? Okay, so it can have only two states. Let's say the dependent variable is that yes or no. Okay, are you going to be selected, or what's the likelihood a candidate will be selected or not selected? Okay, so now the dependent variable has only two possibilities. Okay, it has usually only two states. Okay? Typically we say 0, 1. Okay, it's a dichotomous variable, so we can fit a probit model or a logit model to those. So you can see that there are different flavors of these, but some of the problems that we kind of talked about are applicable to all these, right? So in terms of the things that we need to do before running those and things, some of the post estimation. So Stata is pretty good in that sense that you can actually what are the post estimation commands that I can do? What are the ones that I should be doing? We also have examples in the manual itself. So if you spend time, you can start. So like things that we did today, I would like you, some of you, come and spend time trying to run those things. Okay, just sit by yourself, use the file that is available, okay, and try to see that if you are able to run, because and then just run one at a time to see what it is showing. Okay, so if you select many, then you'll not know which line was doing what. Okay, but if you run just one at a time, then you will know what exactly this is doing. Okay, like somebody was asking that why you are saying compact. Okay, do that, take that out, okay, and see that what's the difference it is making. But you can also go back to the manual, okay, search for that. Okay, what is why it is being used? So that's a very kind of a rich resource. So now we are looking at a panel data set here. There are two kinds of model we can fit, okay, which are based on, depending on which assumptions are valid. So the two types of models that we can fit here, we are looking at what we call a random effect model or a fixed effect model. Okay. Now, and the hypothesis, the way, so many people don't know that, like how you are stating your hypothesis. Is it a random effect hypothesis or it's a fixed effect hypothesis? Does anybody know that if you are writing, let's say, a hypothesis for your project, what a hypothesis for a random effect model would look like what would you say, and how would you say if the hypothesis is stated for a fixed effect model? So we are looking at, so the fixed effect model is which within difference. Let's say you are looking at companies. So your fixed effect hypothesis would look like that, okay, as firms grow or do this, we expect this is to happen, whatever is the dependent variable. But if you look at a random effect model, so we are looking at, okay, let's say the bigger the firm, the larger is the effect. So we are not looking at a within firm modeling, but we are looking at, okay, the larger companies across my sample will have this kind of prediction. So that is a difference. So many people, because you can run all kinds of things. If you run in a data fixed effect, it will give you an output for a fixed effect. Okay? You can run any random effect model, it will still give you a random effect model. So there are some differences, but then there are other things that you can do to know which one is more appropriate. Okay? How many of you know that how to choose between a random effect model and a fixed effect model in a panel data set? Yes, you can do the Hoffman test. So it's simple is, right? So when you run a model, you store the results. Okay, so there is a e-store parts. So you store it model. Okay, this is a fixed effect model. You run and you store the results. You run the next one, you store the results, and then you compare. You can use the Hoffman test to see that whether the random effect model but there are also theoretical reasons. So the one that I was talking to you was not from the empirical perspective, but from a theoretical perspective, that the phenomenon that I'm trying to understand or is of my interest is I am looking at within individual differences or a within firm differences, that how, what a company or what a unit, what an organization has done over a period, the same organization has done over a period of time, that how that has impacted that company or an organization's performance. Okay? So there may be a theoretical reason to choose one versus the other, and the other is that you are theoretically you are neutral, but you are looking at empirically whether the estimates are similar or not, or whether I can use the fixed effect as well as the random effect model. Okay? Now, in the random effect model, the intercept, okay, it must be exogenous, means it must be uncorrelated with the x's in the model, the other predictors in the model. Okay? So the alpha is the intercept, and it must be uncorrelated with the variable. But in a fixed effect model, it is possible that the firm, so now you can see here that alpha, here I am writing alpha, okay? But here I am writing alpha, and there is a subscript I, okay? What's the difference between this alpha and this alpha I? It varies for each I, because I is the unit, whatever is the one, and I'm expecting that there is a unique intercept for each of my units that are. So if I'm looking at, let's say in this set, there are 600 companies. Okay? So we should have 600 slopes for this one. Okay? But there is one, but it is not changing with time. Okay? So now you can see here that the slope is firm specific, but my assumption is that it remains same for the firm or for the unit over the entire observation period. Okay? That's the assumption we are making, because you can see here there is no time here. Okay? So y is changing for firm and time, so there is a subscript is I and t here, okay? But the intercept is only firm specific or the unit organization specific. The x's are both I and t. The errors are also changing with the organization and time. Okay? But we are assuming that the slope remains constant for each entity that is we are exploring that. Now, in order to do this, okay, and so we are using the same variables that we have. So you can run the same one, the workshop that you created, the file. Okay, so it's the same data set we are using, and we're just changing. Now, instead of running, ignoring that these were like for grouped data, so we ignored the group structure when we run the regression we run in the morning session. Okay, so we ignored the group structure. Now we are saying that no, there is a group structure and it's a panel data set. So if you look at the changes that are happening, so one change is that instead of running regress, it is running XT reg. Okay, so XT is, they have created this system that the moment you see the XT, you know that it's dealing with a longitudinal time series or panel data. So this is an XT is for that. Okay? So this is how they have created that it communicates immediately that what you are using and what kind of data you have. So that's one part. Now the rest of it has not changed. Okay? If you look at, I'm still using the same DV. Okay? IV remains the same. The one that I have running here, it was the one that we ran the last one, okay, where we identified the issues, we plotted the residual with the fitted values and see that, okay, we modify the function because we noticed there were some functional misspecification. Okay? And because we had fitted, so we're moving in the right direction. Okay? So we just made it these sales as a curvilinear variable. So we have both the linear part as well as the curvilinear. We added the productivity, we added an interaction between R&D and the employees. Okay? Now, in this data, the interactions could be two different types of variable. Okay? The interactions could be between two dichotomous or categorical variables. It could be between a categorical and a continuous variable, or it could be between two continuous variables. Okay? So you can see here that I am writing C dot RD and then the pound sign C dot employees. Now the C is telling Stata that RD is a continuous variable. Okay? The employees is also a continuous variable. So it's an interaction between two variables. Both variables are continuous variables. Okay? Now I have I here. It is now telling I that it is a indicator variable. So, and instead of creating, sometimes you call dummy variables. Okay? So some people, if they are like doing it manually a little bit more, they will create these dummy variables. For each year, they will create, okay, I have 20 years data, you will create 20 dummy variables, each one for, okay? But the data does it for us. We just tell that, okay, we have a year, because we know that we created for 20-year data, okay? And we are now telling that it's an indicator variable. So if you don't tell it, it will treat as a continuous variable. So it's just, we'll look at, okay, you have 1990, 1991. So it's look at a variable that is changing from 90 to 91 to 92, as opposed to treating them that, okay, these are all the dummies. I'm looking at each year is different. It's not an increment. From 90 to 91 is not a 1 year increment, okay? But 90 and 91 are two different boxes, and I want to control for anything that is happening 90 is specific versus a 91 is specific, okay? So we have to be very careful in terms of, because a slight error here has a very different, the data doesn't know, okay? It is telling it, it will treat that it's a variable which is changing from 1991 to 1992, 93, versus if you know that, no, this is not what it is, the year is a dummy variable, so I want to do it, so you just put it in the I. Now, if you look at, so RE is for the random effect model. So the commands are like simpler to know that it's a random effect model. And if you run it, then now you can see here, this was the assumption, okay? That we said that the error term must be uncorrelated with the excess. Okay? Now you can see here, okay, it is showing that this was the assumption has been made. Okay? We can always go and test for the assumption. Now if you look at the output, okay, obviously the R square is very, very high, okay, because it's our own data set, and we put pretty much all the variables that were there. So you can say it's a very, it's capturing the, if you look at the coefficients, okay, still it's not coming very close. The sales part is still, so now we have the linear coefficient is negative, and the curvilinear is also negative, okay? But it is slightly less negative. This is a little bit more, okay? So it is decreasing, but decreasing at a decreasing rate in terms of how the effect is happening. If you look at the interaction, the interaction coefficient is positive. Many times, so if somebody wants to, if you run this model, okay, and you want to know that how much effect of R&D is on the firm performance, okay? Now, can you look at this coefficient and say that how much is the effect of R&D on performance, or you will look at something else? Let's say your goal is to tell that how R&D is impacting firm performance. Okay? R&D is the R&D variable here. Okay? And one of the things you have hypothesized is that how companies doing R&D impacts their performance. So you have a hypothesis about that. You got this output. Okay? Can you conclude that the R&D is positively impacting the performance, or you want to look at something more or less? You can you see the output from there? Okay, yeah. positively impact? Maybe. But is it this table that you should be looking at, or is it something else you should be looking at? Those are there. Yeah. Anything else? Anybody else? Okay. So sign and size are here. Positive. Okay. So this is what would you say, or I'm just asking, is there some other opinion in the classroom? Okay. You have to be very careful. Now, if you look at very simply, that write the equation here, okay? Y will be, let's say, alpha plus, let's say, RD, beta, R&D. But there is an interaction in the model, okay? And the interaction is between that variable you were interested, okay? So it's not just the effect of R&D is not just this much, but let's me put it, it will be also R&D, okay, multiplied by employees. Thank you. And whatever is the coefficient, let's say RD EMP, okay? So if you take the R&D out from here, so it will be now do you see that? So you have to do a joint test. In this case, the signs were like similar, okay? So the chances of making a mistake, if like you can say that, yeah, because they were more positive. So that positive part was not incorrect to say, but the coefficient you were looking to claim that was not right, okay? Because it has another component. So R&D is not just impacting through this, but another beta coefficient, which is multiplied by the employees. These two together are impacting or showing that how R&D is impacting the dependent variable that was part. And this is something I have seen even very experienced researchers making this kind of mistake, okay? That they are looking at a wrong model. So it's not on and in some people I have also seen that they have an interaction, okay? Can you let's say you are interested in knowing the effect of R&D and employees. If I keep R&D here, okay, and I keep this one, the interaction term here, will it be okay if I don't keep the employees in the model? So you understand what I'm asking? Okay. So I have this model. The only thing I'm asking, so there is a interaction between R&D and employees. In the model, I have one predictor is R&D, and the other is the R&D multiplied by the employees. Okay. Is it okay if I don't keep employees in the equation or as a predictor in the model? Somebody said something. Who is saying? You. Yeah, go ahead. Yeah. So it is very important that if there are two variables that are interacting, they also appear as a stand-alone in the model. Okay, so those two, along with their product term. Okay, so you might come across people doing this kind of mistake in specifying the model, because if you do it like Stata or anyone, they are not flagging that. Okay, that there is a thing missing, and it's going to not automatically take care of it. But if you follow a slight different approach, that how you actually state the so you might have seen that some people manually create a variable which is a multiplication of R&D and the employees. Okay? So let's say think you have an Excel data set. You have one column have R&D, one column has employees. You might see some people that they will, because they have an interaction which is multiplied by R&D and employees, they will create an Excel sheet, okay, and they will include the product of those, okay, which is this one. Okay. Do you see anything wrong with that? Or is there anything that may not be right? Do you understand what I'm saying? Okay? So you have two variables, and then there is a interaction, which is the product of those two. So you are, let's say, building the data set in Excel form. So you have one column has the variable 1, and the variable 2, and the third one you manually computed that. And Excel, all you need to do, like, do once and drag it, and it will fill everything. Okay, so it's not like a lot of hand coding or anything needed. You just give once and drag it. It will fill up the product of 1 versus 2 and the third one. Okay, and in the regression, now you can enter those two. Okay? So column 1, column 2, and the column 3rd, which is the product of the 1 and 2. Okay? And then there may be others, but we are focusing on those. Okay? Is there any issue that you see that there may be something that we have to be careful about? Multicollinearity is there. Let's say you can do a centering, okay, if that's an issue. Okay, so let's say you do the mean centering and you can do a mean centered one. Okay, possibility. But the approach I was talking about. Okay, so that how you are doing it. Multicollinearity is a different point. I'm trying to get a slightly different issue. But multicollinearity, in order to address that, okay, you said, okay, what's the mean, and you are kind of looking at the deviation and put those as the variable and the predictor. So if you put in this data, okay, let's say I could have created a third variable myself, okay, which I can generate. If I have write in this data, I could have written that gen, okay, and I'm saying, let's say RD/E is equal to RD multiplied by employees. This command in its data will create a new variable, R&D E, which will be multiplication of R&D and employees. Okay, and then I can write, let's say we're still running the panel. I can have x2 red, right? And I can write, let's say, the y. I'm just writing y right now as a dependent variable. Okay? So the first one that shows up is the dependent variable. Now I can write RD, and I can write, let's say, employees. I'm just writing EMP for the employees. And the third one is the, let's say, R&DE. And there could be other ones, but right now I'm focusing on this and how to kind of look at it. Okay. Now, if you look at this, what kind of, do you see any problem with this? Have you done it before yourself? You have never done it? How do you do it? If there is an interaction between, let's say, two variables, how do you write your equation in terms of running, whether you can run in SPSS or R or any of that? It doesn't matter. There is slight variation, but the structure is the same. Okay? You understand one, you can always do in the other, which is fine. See, the point I'm trying to get at is, okay, now, in this format, when I've written the one that is showing up here, the program knows what? Program knows here that this is the one variable here. It is a product of two variables. Okay? The program knows that it's a product of this one and employees who are some, okay, these two, okay. So it's a product of these two. So if you have to do the joint test, okay, you can do that. But more importantly, when you have to actually plot a graph, okay. Now think about when you have to plot a graph, then you have two variables, okay. Let's say R&D and employees. Let's say you have 5 values for R&D and 5 values for employees, okay. And you're trying to kind of use that to predict the Y, as those values are, what will be the value of Y. Okay? So those are the inputs you're trying to graph using those ones. If you follow this approach, okay, and you can try that, okay, you can try yourself on your own, okay. Just when you go back, just do the same thing, okay, what I'm telling you to do here, and then you'll see the difference. That okay, what is that? You'll get exactly the same output. Okay, so when it comes to this output, okay, so this instead of this variable, we created a new variable, okay, which is the RDE. Now you will get exactly the same coefficient, okay, but with a caution. Stata does not know that the one that is here, which will be now show up like this, RDE, we just gave a name, okay, is a product of these two. So when we try to graph a between a variables, we try to vary that one and we hold the others at a certain values, okay. So keeping the other variables in the model, let's say at their mean value, we want to vary the ones that we are interested in graphing the result, okay. So we would let the R&D vary, we would let the employees vary, the values that we have chosen, while holding the other variables at a certain value, okay. Usually the mean is kind of a good fixed value. To keep the other ones at their mean value, you are moving this, okay. Now what the Stata will try to do, it knows a mean value of this variable too, okay. R&D and employee, because it's a variable you created, there is a mean value of that too. So what it is trying to do here in this one, if you write this one, so this table will be identical, okay. There will be no difference between this result and this result. But the difference will start hereafter. When you are trying to plot the graph, then what it is going to do is, it's going to force this one. So it's going to hold all the other variables, like sales here, innovation, these ones at their mean value, okay. In the process, it is also going to do, it will keep this one at its mean value. Is there any problem if it does that? Do you understand what I'm trying to say? Okay. So I'm looking at R&D and employees, okay, how the interaction between those as a function of each other is impacting my performance, which is my dependent variable. Okay. That's what the result I want to graph. Now, in order to do that, I want to keep the other variables at a constant. Okay? So I'm not varying the other ones. I am holding others constant and letting these vary and then graph output. Okay? So I have interaction in mind, and I'm doing this. What is the difference between this and this? I got the exact identical coefficient I should be getting. Okay? So you run it on your own. Okay? When you go back, look at this one. Okay? All you have to do is you have to generate a variable here, okay, which is a product of, so you can write gen, a new variable name, and simply the first one, and the star is the product between the other one. Okay? So write it down and run the result. Okay? We will also show you, maybe tomorrow, okay, in the beginning, try to run and plot its interaction graph. Okay? Take that as an assignment for you. Okay? That what I'm asking you is this. This is the model. You have the data already. You have it. Right? Take this data, plot the interaction between the R&D and the employees. Okay? We want to graphically show that how the interaction between these two is reflected in terms of their impact on the y, which is the dependent variable. Can you try doing that? Okay, so we'll stop sort of here, okay? Because if you go too fast in too many things, then you will not absorb everything. So what we want to do is there are certain things we do, okay? Now the file should be available, the Word file that we were trying to save. I hope it is like saved on the Google Drive. If it's not, when I go back home, I will kind of do it just to make sure that it's available, but it should be there, okay? Because this is what we have done so far. So what I'm asking is to you go to each step yourself, okay? One by one, the date, so except the make directory one, okay? Because the directory is already created, okay? Put the product symbol, the star, in front of those, the make directory command, so it will become green, okay? That means you are not repeating those because the directories have been already created. So you put a star on those in your do file. Go each one step by step, okay? One by one yourself. Maybe we have 50 or 60 lines, okay? So what I want you to do is just go by each one of those, okay, yourself. See if there is anywhere you get stuck. That's one point. It's possible that you may not follow that, okay, what exactly we're trying to do here. Okay? That's one possibility. But let's say if you're not stuck anywhere and it runs because it has been running, so it should run the commands because we don't need anything from outside. Okay? So everything is self-contained here. We are not dependent on anything else. There are a little bit of pieces, which there are some where I'm importing I'm just trying to show something like how merge different like data files and things like that, and we will probably also do a little bit of two files, and I would like you to sort of connect those, right, tomorrow, that how to actually connect, what kind of problems happens when we are matching different types of mergers. It's called like one-to-one merging two data sets, one-to-many, and many-to-many. Okay, those are three sort of variations that can happen in two files, that how you connect. Okay? So it's in one, there are many, so each one has to match with the, every time the second one kind of shows up in the other file. That's called one-to-many merger. So it's 1:m in this data. But the task for you is that you run everything that we did today, okay? You go through that and show me the graph. The graph we have not done, okay? But I want try on your own. The manual is there, okay? So there is, the part is that we have to figure out a way how to teach ourselves, okay? That, okay, now the resource is there. It is possible to read it and do it. Give it a try. Okay? It's okay if you don't get it, okay? But I want to see it that you have tried, okay? And if you have tried and you haven't got it, then we also know which part you did not get, okay? Where we can focus our effort and see, because these are simple things, but once you have actually understood these, because the problems we talked about, okay, whether it's a panel data set, time series data set, some of the problems are similar, okay? The endogeneity issue, heteroscedasticity issue, omitted variable bias issue. We'll talk some more, maybe the sample selection or some of those things which we will, like the head selection model, instrumental variable regression model, that some of those I have saved it for the last day to do it, because those are, once you have kind of through all of this, then we focus on some real big ones where we kind of hit the most advanced issues and most complicated issues and how to identify. So we have to understand few things, okay? How to identify problems, that's one part. The second is, once we have identified how it is impacting my estimates, understanding that part, okay? If this is a problem, should we worry about it, okay? Why should be the worry? What it is change, what it will not change, okay? What is my goal? If the goal is this, should I worry about that problem? Because in no data set you will get which all these assumptions are valid. Okay? There will be violations of the assumptions we said that has to be there. Okay? So in any data set that you have, some, one, two, or maybe several of those assumptions will be violated. but we need to understand, okay, what happens if those assumptions are violated? What is the solution that is available? What it does and how it does and why? If do we need anything more? Okay? So, do you follow what I'm asking you to do when you come tomorrow? What? Everybody will have one graph. I had asked you to have a tent card with your name, but I didn't see anyone bringing that. Okay, so that's okay. That's fine. But tomorrow when you come, okay, I know, I mean, you're busy and you have other things to do, but this is one part. Okay, the important reason that you are here, and we want. So, as a instructor, I always feel that it's my duty to make sure that my students actually do what I want them to do. Okay? That unless I see them doing it, I feel that I am not being successful. I don't see myself as successful. So I want you to try. And the only thing I actually care about when the person is trying. Once you have shown the willingness to learn, you already won most of the battle. Okay? There is nothing out here that is not available if you go and read this stuff. Okay? So everything is available. It's just a matter of getting a start. There are some things which is the fear of unknown. Okay? So let's say this is something you have not done before. So there you are hesitant to that. Okay? Is it something different? But as you start getting into that, you realize, oh, it's not that different from what I knew using this or that. Okay? So there are some variations, but most of the things can be done. But there are some bigger scientific issues that we must be aware of and how to address those. Okay? So I'm expecting to see nice graphs tomorrow from each one of you. Okay? The graph will show what? Interaction between and if the y. Okay? So I will have very nice looking graphs. Okay? That's why I'm kind of waiting for. Okay? Am I going to see those? Because obviously I haven't talked about it, but that's part of it. Okay? So and especially it becomes very important because unless you visually see the effects, just by looking at the coefficient, it doesn't show us the full picture of how the effect is changing over a different range of these different variables. Okay? So the nature and the impact, the intensity, the confidence interval, when you plot all of those, you will see that it may vary, especially when we get into any kind of a nonlinear model, because it's in the linear model, the variables, they appear, the coefficients in an additive form. Okay? But in a nonlinear model, they appear in a multiplicative form. So each of these are multiplied with each other. So they are never same. The graphs are more interesting, but very challenging to do as well. Okay? So let me stop here. Okay? And thank you very much. And I'll see you tomorrow. Okay? Yeah.